Okay, for this graph, I just didn't label it, so I'm going to add my label here. Y equals 3x squared. Okay, now we're going to move on to the next one. So if you have two graphs on the same grid, you should label both of them. Let's go on to the next. Okay, here we're going to graph y equals half x squared and put the transformation. Let's first graph it this time, and then I'll add the transformation, explain it. So we're going to start off, we use the red color here, we're going to start off with 1, 3, 5, our base function, and we're going to multiply by the number in the front. So in this case, it's a half. If you want, like a lot of people like decimal, we're going to multiply by 0.5. So 1 times 0.5 is 0.5. Okay, 3 times 0.5 is 1.5. 5 times 0.5 is 2.5. Well, I can guess the next one, 0.5, 1.5, 2.5. Next one's going to be 3.5. Okay, let's go graph. So go to the graph paper here. Okay, so we're going to start at 0 here. We're going to put a little dot at 0. We're going to go over 1. And let's go here, you go 0.5. Well, you got to go half a square. So you put a dot at half a square right there. Then from that one, you go over 1. And the next one you go, okay, so first we did 0.5. The next one you do 1.5. So you go over 1, and then there's that 0.5. There's 1.5. Next one, well, 0.5, 1.5, 2.5. Go over 1, 1, 2.5. Go over 1, 3.5. So you go 0.5 up, 1, 2, 3. And you could keep going, but we'll just stop at this many points. Same thing on the other side. Over 1, up by 0.5. Over 1, up by 1.5. Over 1, up by 2.5. Over 1, up by 0.5, 3. 1, 2, 3. It's symmetrical. The axis of symmetry is down the middle. It's symmetrical on both sides. Let me try to connect these points with a nice curve as best as I can. I'm coming down here, connecting, and coming up as best as I can. And I put my arrows on the end. And let's label it over here. Y equals half x squared. Okay, y equals half x squared. It's a little bit messy there. Very hard to write on the screen. Okay, let's go to the computer software again. Okay, again, you can go to GeoGebra, find it. Now we have our two previous ones. I'm just going to go here, and I'm going to go new. I'm not going to save this. Don't save. And I'll type the next one. Okay, y equals 0.5x, and over here, power of 2. Okay, and I can use my mouse to scroll here. And when you click on it, you can see here. So look, you go over 1, up a half. Over 1, so that's 1 to 2, up 1.5. It might be easier to see here. So over 1, up a half. Over 1, there's a half, 1.5. Over 1, up 2.5. And you keep going. So that's that one. Now this has been compressed. So let's just look at the base function. So let's look at the first one, y equals x squared. Okay, so what's happened here? This green one, this is our normal one, has got squashed. It's got all the points have come down. So we call this a vertical compression. They've all come downwards. So this particular one, we got a vertical compression. So what do we write over here? So since it's a decimal, and I mentioned that before, decimals and fractions between -1 and 1 are compressions. We're going to write the word here, vertical compression. So here we're going to put vertical compression by half, 0.5. Got compressed by half, got shrunk by half. Okay, that's that one. Now let's do B. We're going to do the exact same thing. I'll just change the color up. We'll use that blue. I'm going to write with this blue one here. I'm going to write 1, 3, 5. I'm going to multiply that by -2. So we're going to multiply it by -2. So this is the first one we've seen a negative. So far, we've seen all positive. So even here, positive 3, just a 1. Okay, there's a positive a half. Now we got a negative 2. So here's what happens with a negative. You get negative 2, negative 6, negative 10. So all these become negative. Let's go graph it. Let's go see how it looks graphed. Okay, now we start here. We're going to use that blue color. Always start at 0, 0. We always go over 1. Now, negative 2, we're not going to go up by 2. We're going to go 1, 2 down. That was the first value, negative 2. Right here, negative 2. Next value is negative 6. So we're going to go over 1, 1, 2, 3, 4, 5, 6. The negative next one goes over 1, and then you got to go way down there. We can't fit it. So we're only going to do 2. We're going to just do these 2. On the other side, over 1, down 2. Instead of 3, 3 times 2 is 6. So over 1, down 1, 2, 3, 4, 5, 6, and we put a point. We connect all these. So again, the negative one opens down. Okay, we call this a reflection. Oh, my graph is not perfect here. I think you guys can do way better than me on the screen. Okay, so this one is y equals negative 2x squared. So the negative ones open downwards. Okay, they open down, and we call this a reflection. Okay, let's go back to this one here. So let's now add another one here. We're going to click here. Okay, let's add the y equals negative 2x, not z, x squared. Oh, I can't see it. Okay, it's down here. So again, look, we went over 1, down 1, 2. Over 1, down 6 to the negative 8. Okay, and then over 1, down. So the negative one opens downward. But we call this a reflection. It's as if it's reflected down. So it's a reflection in the x-axis. So we're going to write that in our transformations. We're going to come back here, and you guys hopefully have more room than me. I'm going to write it right here in the transformation. Okay, so the transformation here, I'll just hopefully you can type right here. I'll just type underneath. Okay, the transformation, where's it? Reflection in the x-axis, so not the y-axis. Okay, and then it's still a vertical stretch. It's a vertical stretch by 2. So it's still got skinnier, it's still got pulled. So it got reflected in the x-axis and stretched by 2. Okay, so the 2 here tells you it's stretched. Unless it's a decimal, so unless it's like 0.5 or a half, it gets stretched. The negative tells you it opens down or it's a reflection in the x-axis. Let's take one more look at that here. So see, this is the base function, the green one. Okay, it got stretched and it got turned, or on the x-axis, it got turned, reflected on the x-axis. Now I would like you to try the rest of them. Again, you can always go to this software, GeoGebra, and check your work. Okay, so I would like you to try the rest. Oh wait, there's one more question. I almost forgot. Okay, one last question here. Okay, and I'll type it. Okay, so we got one last question. I'll type it so you can read my writing. Just by looking at this 10x, you can state the transformation. You do not have to graph it. So here, the 10 tells you it's a vertical stretch. So you'd have a vertical stretch by 10 and nothing else. Okay, let's do the next one. Okay, this one, you see the negative. The negative tells you there's a, and I'll put 24 so I can write both in the same line. Okay, tells you that there's a reflection in the x-axis. That's what the negative tells you. Okay, this negative in the front. Now this is the decimals between -1 and 1. Okay, so it's a point something. This tells you that there's a vertical compression. So vertical compression by 0.1. Okay, that's what that tells you. Okay, so anytime there's a decimal or fraction in here, it's a compression. Okay, let's do the last one here. Okay, again, the negative, right here, the negative in the front, that tells you it's a reflection. Okay, I'll try to fit it with the big in the x-axis. I can put another line. And then the 20, since it's not a decimal or a fraction, it's a vertical stretch by 20. I want you to try the other ones for this question, and I also want you to do the other graphs.